Okay, welcome, Algebra 1. This is your first lesson in your first chapter for the unit 0. They call it 0 because it's pre-algebra. It's stuff that we've already kind of learned, but we're just reiterating or going back so that we make sure we have this foundation for when you start chapter 1. Let's start with numbers. What are natural numbers? Natural numbers are numbers such as 1, 2, 3, 4, so on, all the way approaching infinity. Now you think about, what would you naturally say as a child when you start to count numbers? You'd start with 1. You wouldn't start with 0. When you were a baby, you didn't start with -7. You started with 1. Whole numbers are natural numbers, but they include 0. Integers are whole numbers that are also negative. So we could have -3, -2, -1, and 0, 1, 2. So this terminology is just important. If a question says using an integer, they're specifically talking about certain numbers. And there's also, all of these are considered rational numbers, but rational numbers aren't just whole or natural or integers, they're also fractions. So a rational number is a fraction. We say it's a fraction with a number p over a number q. So for example, 1/5 or -2/3. Those are rational. You could have 7, because 7 is technically over 1. So we say it's p over q, where p and q are integers. So any of these numbers, okay? But q cannot be 0, because if q is 0, it's in the denominator. And if it's in the denominator, technically a fraction is division. Why couldn't you have 0 in the denominator? Because you can't divide by 0. I don't know if you remember that. So let's look at an example. So say we have 10 divided by 2. What does that equal? It equals 5. Why? Because 5 times 2 equals 10. Checks out. All right, what is 6 divided by 3? Well, that's 2 as well. Why? Because 2 times 3 is 6. Now say I had 5 divided by 0, what would you tell me? Well, some people might be like, oh, well, it's 0. It's not, because 0 times 0 should be 0, and it's 5 according to this. That doesn't work. Well, what about 5 divided by 0? Well, 5 divided by nothing, maybe it's 5. Well, what's 5 times 0? 5 times 0 should be 0. So this breaks definition. The definition was going back to where you came from. You can't do that here. It breaks definition, so it's undefined. So why can't 0 be in the denominator? Because it's undefined. All right, going to terminating and repeating decimals. It says use division to write each decimal rounded to the nearest tenth, or I'm sorry, nearest thousandth. So 4 divided by 5. So let's go back to pre-algebra. 4 divided by 5. Well, we can't do that, so we need to borrow a 0. Do you remember that? So it's less than 4, so you have to put 0.0. So put a point up here. So how many times can 5 go into 40? 8. 8 times 5 is 40. When I subtract, I get 0. We're done. So 4/5 is 0.8. 3/4. 3 divided by 4. Can 4 go into 3? No. Okay, can 4 go into 30? Yeah, it can go in 6 times, so that's 24. Can it go in 7 times? Yeah, that's 28. Can it go in 8 times? That's 32. It's too big. So let's stick with 7. So you pick the highest number it can go with. So 7 times 4 is 28. When you subtract, you get 2. So we have to keep going. Our remainder isn't 0. Bring down another 0. How many times can 4 go into 20? 5. 5 times 4 is 20. 20 minus 20 is 0. So 0.75. Now, can you use your calculator? Sure. But here's the problem. As you get into higher math, you need to be able to do these things. I had a student once who was going into the military, and he had to take a test that's called the ASVAB, kind of like the SATs for college. All of it was just problems like this. He was not allowed to use a calculator. He had to use mental math. It'll make your brain stronger too, but you can use a calculator as well. All right, 4 divided by 11. Well, this is weird. There's a squiggle, which means an approximation. So that tells me it's probably not going to be nice and cute like these ones. So let's try it. 4 divided by 11. Well, 11 can't go into 4, so we use 0. Can 11 go into 40? Well, times 2 is 22, times 3 is 33, 4 is 44. So we're going to use 3. 3 times 11 is 33. When we subtract, we get 7. Bring down the 0. Can 11 go into 70? Well, 66, 77, yeah, let's use 6. We get 66. Subtract, you're gonna get 4, bring down the 0. Can 11 go into 40? Yep, 3, 33. Subtract, you get 7, bring down the 0. Can 11 go into 70? Yes, 6. 66, subtract, I see a pattern. It's gonna be back and forth, and we're gonna get 3, 6, 3, 6, 3, 6. So since these both numbers repeat, we put a bar over the 3, 6 part. We don't need to write this because that bar means you're just gonna keep getting 3, 6 over and over and over again. Okay, so terminating and repeating decimals are actually rational numbers. So when we went back up to rationals, it's saying where you can be written as a fraction. You can be written as a fraction, you can be written as a fraction, and you can be written as a fraction. So terminating decimals that stop are rational, and repeating decimals are also rational, okay? What about square roots? It says find the square root or the principal square root, which is just the positive square root of the following using the graphing calculator. So you can turn on your graphing calculator. If you have a scientific one, that's fine too. This one's a little bit older model. You'll probably be using a newer one, but you hit second, and then you go to the square root button, and I want the square root of 16. And that's 4, yeah, because 4 times 4 is 16. And that is rational. It's also an integer, and it's also a whole number, and it's also a natural number. Square root of 7. Go to second, square root. What did I do that for? Second, square root, 7. Oh, that doesn't repeat, and it doesn't end. So it's an irrational number. So it's our first irrational number. It can't be written as a fraction with p over q. Square root of 144, we should know that. That's 12. So it's the same thing. It's a natural number, a whole number, an integer, and rational. And the square root of 11, I don't know that one offhand. Let's try that. Nothing repeats, so it's irrational. It says circle the rational. Swoop, swoop. Okay. Let's get it back in focus. Okay. Flip the page. Ordering numbers. The number line represents the entire set of real numbers, rational and irrational. Each point represents exactly one number. This allows the numbers on the number line to be ordered. Numbers increase from left to right. Insert an ordering symbol to make each statement true. So which one's bigger, 5 or negative 7? 5. So we're going to say 5 is greater. 1/2 or 8/16. Well, that's reduced. This one isn't. I can cut 8 in half and get 4. I can cut 16 in half and get 8. Oh, I could have reduced it actually more. Cut them both in half to 4 or 1/2. They're actually the same. So they're equal. See, I didn't know that. I could have just done 8 divided by 16 in the calculator. 0.5. Well, I'm going to go to math. I want it as a fraction. There you go. I could have done that too. This uses our brain more. What is greater, negative 4.8 or negative 4.7? Well, if they were positive, which would be greater? This one. But since on the number line, negative 4, negative 5, negative 4 is actually closer to 0, so negative 4 is actually bigger. So therefore, negative 4.7 is actually bigger. So it's less than 4.7. Or you could say negative 4.7 is greater. Here, well, I can't tell. Well, I know that if this was an improper fraction, you'd take 6 times 5, which is 30. And 30 plus 4 is 34 fifths. So we have 34 fifths and 15 fourths. What you could do is just do this in the calculator. 34 divided by 5, 6.8. 15 divided by 4, 3.75. What's obvious, this is greater, so go back to your original statement. 6 and 4 fifths is greater. You have to go back to the original number. All right, so it seems a lot, but it's just a lot to review. There's a few lessons in one. When we get into the first chapter, it won't be as quite like this, okay? Opposite and absolute values. On the number line, two numbers that lie on opposite sides of 0 and are the same distance from 0 are called opposites, like negative 4 and 4. Okay, they're opposites, they're negated. Evaluate each expression. If I negate the negative, then it becomes a positive. You can put that in your calculator too to just be sure. You hit the negative button, parentheses, negative 2/3, 2 divided by 3. Close it, enter. Oh, I don't like the decimal. Math button, fraction, enter. 2/3. And negative 0. 0. Well, 0 is not positive nor negative, so you could say there is not a negative 0, or you could say 0. 0 is neither positive nor negative. So you could say that doesn't exist, a negative 0, or you could just say it's just 0. The opposite of 0 is 0. All right. You have to subtract the 2 inside first. So you could say 6.2 minus 2.7. Oops. And you get 3.5, or you could just do it off to the side. 6.2 minus 2.7. 7 can't go from 2, so we cross this out and make it a 5. We borrow it, make it a 12. 12 minus 7 is 5. 5 minus 2 is 3. So it's a negative quantity 3.5, which is just negative 3.5. Absolute value. It's kind of like opposites in a sense. Distance away from 0 is what we're talking about. So the absolute value of a real number x is the distance from x to 0 on the number line. The symbol absolute value x means absolute value of x. 2 and negative 2 have the same distance from 0. 1, 2, 1, 2. They're each 2 units away from 0. So if they ask for the absolute value of 7, how many units is 7 away from 0? 7. If I look at the absolute value of negative 14.2, it's saying how many units are there till I get to negative 14.2? Even though it's negative, it's just because it's direction. There's still a positive distance. Well, this becomes 13. So the distance from 0 to 13 is 13. 5 minus 7 is negative 2. So what's the distance to negative 2? 2. These bars are simply asking what is the distance. Okay? All right. Last part, multiplying and dividing fractions. Very simple. When you multiply, it's the easy one, you just multiply across. 20 over 15. Well, I see they both contain a 5, so I'm going to remove a 5 from both, and I'm going to get 4 over 3. You could have beforehand saw that that was going to happen and removed a 5, and 10 divided by 5 is 2, and got 4 over 3. Either way works. I tend to like going across than reducing. Here, I have a mixed number, so I need to make it into an improper fraction. 1 times 2 is 2, plus 1 is 3. So we're going to multiply by 3 halves. You could just cancel out the 2's and say you get 3/5. Or you could have done 6 over 10 and then reduced it, cut each piece in half. Okay, so you just multiply across. What's the reciprocal of 2/5? 5 halves. What's the reciprocal of 2? Well, technically that's 2 over 1, so 1 over 2. Dividing by a fraction is simply multiplying by the reciprocal. So if I take 10 and divide it by 2, that's the same thing as saying 10 over 1 times 1/2, which is 5. So if I divide by 2, I'm multiplying by a half. If I divide by a half, I'm multiplying by 2. Example, 2/5 divided by 10/3 is the same as 2/5 times 3/10. It's going to be 6 over 50. Okay, we can reduce each in half, and you're done. Always want it most reduced form. This technically is a negative. Well, 2.5 is actually 4 5/2. So when I divide by a fraction, I'm really multiplying by the reciprocal. So I get negative 6 over 20. We'll just cut each piece in half. 3/10. And that's it. Okay, so it's just a lot of pre-algebra review. You're going to use these notes to complete your homework tonight. Your homework tonight looks like it says page 10, but it's not. It's a capital P10 for pre-algebra. Okay? And then you're going to flip the page and do a few more problems, just 2 problems in each section. Page 12. Page 16, well, capital P, and P19. It's the very beginning of your book. So realize that's a capital P and not a lowercase.